Hi, I'm Jared Younger. I'm director of the Neuroinflammation Pain and Fatigue Lab. I have done a lot of experiments in my career. I've done experiments that were high risk, first in person. I've done some that provided a lot of information that was very helpful for people suffering with chronic diseases. I've done some that ran counter to the prevailing thought at the time. And I've done some that didn't turn out the way I expected. But what I wanted to talk about today was the strangest experiment that I ever conducted. So I want to tell the story. So just sit back for maybe 15, 20 minutes, and I'll tell you about this experiment. So before I was a professor at UAB running experiments, I was an assistant professor at Stanford University running a lot of experiments. Before that, I was a postdoc at Stanford and I was running a lot of experiments. Before that, I was a postdoc at Arizona State University and I was running a lot of experiments there. Before that, I was a graduate student at the University of Tennessee, Knoxville, and I was running a lot of experiments there. But before that, I was an undergrad at Maryville College, Maryville, Tennessee. And that's where I ran my first ever true experiment, which was also the strangest experiment that I ever ran. So, where this came about, probably midway through my undergrad training, I was walking around campus and I would occasionally get this feeling that someone is staring at me from behind my back or behind me. I would just get this feeling and then I would turn around and I would catch someone staring at me. And I thought this was curious. And so I started to keep track of it. And I felt like it was happening at much high frequency or occurring in much higher frequency than you would expect by chance. And so I got really fascinated by this. I was thinking, what is this? Is this coincidence or is there something going on here? How am I able to feel when someone is staring at me? So I looked into whatever work had been done on that, and I looked at all the common sense explanations for that, such as you can pick up subconsciously cues from the environment, like maybe a little flash of something in a window, or maybe something out of the corner of your eye, or a small sound, and it was cluing your subconscious in that something was going on behind you, and that would cause you to turn around. Another explanation is you get that feeling all the time and you check, but you forget all the times that there's nothing there. You only remember the times when you look back and there is someone staring at you. And then there's the possibility that whenever you turn quickly to look behind you, that commands the attention of someone behind you and they look up to see what's going on right at the same second or fraction of a second when you're looking back. And so to you, it looks like they were staring at you, but actually you caused it by turning around so quickly and catching their attention. Those are all plausible explanations. But there was a small number of investigators who were approaching it from a different angle, more of an angle of information being communicated in ways outside of our understood senses. And it had its own kind of mini field in that with that phenomenon and related phenomena. So I wanted to figure out what's actually going on here. What is it? How's that information being communicated? So over summer, I went to Edinburgh. I went to Edinburgh University, and I went to the lab where they conduct some of those experiments. And in doing all the research about this phenomenon, I saw that there were a number of studies being conducted. This was like more than 25 years ago. But I had a problem with the experiments. There were methodological concerns I had. In a lot of the experiments, they would put the person detecting the staring in the same room as the starers. And I never liked that because there's all kinds of ways that information can be leaked when you're in the same environment. And in most every case, the participants were aware of what the experiment was about. And I never liked that. So when I came back to Maryville College, the next semester, I did this experiment, but I wanted to rigorously control every possible way that that information could be communicated using normal senses. And so we had psychophysiological rooms. And these are rooms that have soundproofing. They have an observation glass where you can look at the participant, but they can't see at all through it. And I designed an experiment controlling for sound, putting headphones on them. And I created a computer task, a mild computer task that would take their attention and put it somewhere. And so I isolated everything I could, and I created this deception so they wouldn't know what the experiment was about. I told them that it was about detecting responses to this computer task, which was just displaying words. It was a very minor, low cognitive demanding task. And so I ran the experiment on 27 undergrads, brought them in and ran this experiment. What I was looking at was, is their sympathetic nervous arousal higher when they were being stared at versus not? And so while they were waiting to do this computer task or doing the computer task, I had a random schedule that would tell me to either stare at them through this observation glass, stare at the back of their head, or turn around and look the other way at 30-second increments, randomized. So I would follow the schedule. I didn't know what it was going to be until it actually came up and told me what to do. What we were looking at was called galvanic skin response, or skin conductance. And skin conductance, or GSR, is my favorite psychophysiological measure. And the reason is, this is it. This is all of it right now, or right here. It's cheap. It's very easy to instrument. In fact, I'm going to show you what it looks like. You just slip it over 2 fingers with a little bit of conductant gel. And it's an incredibly sensitive and quick measure of your sympathetic nervous arousal. This is why law enforcement love this tool, because it's really good at detecting guilty knowledge. If you tell them something that only the guilty party would know, you'll get a great, huge skin conductance response. And it works by detecting very slight changes of the sweat on the underside of your hand. Works really well, and it's so sensitive, it can pick up the slightest change in your cognitive state. So I'm going to do this for you right now. And what I'm going to do, letting this stabilize a little bit, all I'm going to do is think about a big spider. And let's see what happens. Okay, so you can see that even just a mental image, and I'm not even scared of spiders. That is a very low arousing stimulus for me. Even that causes a very noticeable GSR response. So that's what we used. The idea was the GSR would be higher when they're being stared at versus not, even though they had no idea what was going on. So we ran the experiment. We randomized, blinded, collected all the data, and looked at the results. And I don't think I showed this before. This is explanations of the staring phenomenon, is the results and the thesis. And what I found was there was a significant effect at like P004. There were 2 conditions. One, they were just sitting there waiting for the cognitive task to begin, and one was where they were actually doing the cognitive task. And I thought, or I hypothesized, that while they're sitting there doing nothing, they would be more sensitive to staring, but when they were distracted by the computer task, they would be less sensitive. And it turns out that was exactly wrong. When they were just sitting there waiting for the task to begin, they did not react to the staring at all. But when they were doing the computer task, we found significantly increased GSR when they were being stared at versus not. And this confused me at first. After I looked at all the data and looked at the GSR responses a little bit more, what I theorized was, while they were sitting there, we didn't have control over their mental processes. And so we had no idea what they were thinking about. Some people were probably thinking about the test they were going to take tomorrow or the argument they had earlier that day. And so there was a lot of noise to the GSR. And I suggested that maybe that noise was covering up what we were doing with the staring. Whereas when they were doing the computer task, their GSR was more stable because it was a very consistent test. And so we had a more stable, quiet GSR signal. And so we were able to pick up on whatever effect of staring there was on the GSR. I don't know if that's true. It was just what I suggested to explain the data. So that was significant. So we found a significant effect. So I wrote up the thesis, and my mentor, Dr. Lori Schmid, said, "This is very interesting. Do not try to publish this until you're tenured." And the implications are clear. Doing something like this in the scientific literature is a career killer, potentially, and you don't want to be associated with something like that until you have a stable, safe, protected job. And so I took that advice to heart, and I didn't publish it. And I still haven't. 26, 27 years later, I still haven't published this. In fact, if I was going to publish it, I would probably do the experiment again with more people and more repeated sessions. There are things I would do different, but I still think it was a very well-designed experiment. I think I did a great job controlling the senses, and so I still don't know why I got this positive result. It could be a total fluke that happens. It just isn't replicable. It could have been that there was something wrong with the room where the information was getting through to participants so far, some way. They had no idea. We asked them. They had no idea what the experiment was about. But you don't know. That's why you have to repeat experiments over and over again. So I'd say it was interesting, but I don't know what to make of it. The truth is, of course, I don't do this kind of research now, and I'm not really particularly interested in the staring phenomenon. What interests me more is just the idea of this sitting here in a binder, and this is the only place where this study exists. And it was a well-designed study with interesting results, unexplained but interesting, but the results aren't available to anyone. This is it. And it makes me wonder how many other studies, well-designed with interesting results, are there in the world that were conducted, but someone was told, a student or an early professor, young professor was told, don't publish this. It's too risky, it's too controversial, it's too confusing. I bet there's a lot. I don't know how many. I bet there's hundreds of thousands. And then a percentage of those, and I don't know what that percentage is, but some of those have something truly, truly important. And that thing that made it so confusing, that's actually the thing that we need to know now. But we don't, because the results were never published and never made available. You can take the best designed study with the most interesting results, and it means nothing if those results don't get out and get to the people who need to use those results. So I think it's really important, really no matter what the experiment is, to at least make the results available. And that's the purpose of this channel I'm doing and why I'm talking about this today. I'm doing these weekly talks to highlight findings both from my lab and from other labs that I think really need to get attention, to get the information to people who can use that to improve their own lives, or to get that information to other researchers who can use that to design an even better experiment that will finally give us the way of treating these chronic diseases. So that's all I wanted to say. Just wanted to tell you about one of the different kinds of experiments I ran. And no matter what the topic is, it is always our goal to try to uncover truths and to discover new things and hopefully things that will make our lives better. So that's it for this week. I hope you can dial in next week, and I will tell you some more stuff about the science going on, and it'll probably be hopefully just as interesting, but probably more relevant to chronic disease. So I hope to see you next week.